fastball quick.
Alright, so right here we have our prototype for number 2 on the problem, our little drug distiller.
Yeah, what you gonna do for cover now?
So what we have on the left is our input, so imagine this goes out into whatever the drugs are coming from. It'll pass over this heating coil, which is not on, and then water will evaporate up through this straw here. It will run through up to here where a cold, in this case a wet paper towel, but something to condense it, is there, and it'll drip off into our little condensate output whiskey glass that we have, very scientific. And then the rest of the now more concentrated solution, because we've evaporated water off and kept the drug in, will run along here and then go to wherever it needs to go. So thank you. This concludes my presentation on my first prototype. So now if our little still had 100 milliliters per minute flowing in with a concentration of 50 kilograms of drug per every milliliter, and going over the heat coil 40% of this solution evaporates, we'll find that the flow rate for the two outputs would be, we have 40% evaporating, so the condensate will have 40% of the 100 milliliters per minute going out, which will leave us with 40 milliliters per minute. The flow out will be the other 60% that doesn't evaporate, so 100 milliliters per minute times 0.6 would get us 60 milliliters per minute.
Okay, I have a medkit for you.
And we can see that our output equals our input, so everything makes sense. We have 100 milliliters per minute going out with 100 milliliters per minute going in.
I see his buddy.
And then for the concentration, since we're assuming that none of the drug is going to evaporate with the water, as we see when we distill, or you make salt. So since no drug evaporates, then that means logically the condensate will have a concentration of 0 kilograms per milliliter. And then down here, we'll use a little concentration of one solution times volume of one solution equals the concentration of the second solution times the volume of the second solution. And since we have flow rates, we'll just take a 1 minute sample of concentrations. So, or for volumes rather. So in 1 minute, we have 100 milliliters, that is 50 kilograms per milliliter going in. And then on the other side, we have 60 milliliters going out as established up here in a minute. So we do the math, we multiply 500 on the left and then divide by 60, and we get that the concentration of the flow out would be about 83.33 kilograms per milliliter.